Hook, have you ever tried to compare two things without having all the right tools? Imagine living in a remote village where you can't find a weighing machine or a measuring rod. How do you know who is heavier or taller? Surprisingly, you can still make assessments just by ranking the individuals based on what you see. Link to CBSE syllabus. Today, we'll explore Spearman's rank correlation, which is part of our unit on statistics in economics. This powerful tool helps us understand relationships between variables when we cannot measure them directly, and it aligns with our curriculum's focus on interpreting data. Why it matters: understanding Spearman's rank correlation is crucial for your everyday decision making and future careers. For example, how can businesses decide between different marketing strategies if they can't quantify public opinion? Spearman's correlation helps them rank preferences and make informed choices. It also underlines the role of fairness and perception in fields like psychology and social sciences. Review: in this lecture, we'll learn how to calculate Spearman's rank correlation and understand its significance in various situations, like measuring traits that can't easily be quantified, such as beauty or honesty. We'll also discuss how it works differently from Pearson's correlation and why those differences matter. By the end of this class, you'll see the world through the lens of an economist and better appreciate how we can extract meaning from data, even when it seems trickier to work with. So, let's dive in and uncover the fascinating ways we can rank our world. Hello everyone, today we are going to dive into an exciting concept known as Spearman's rank correlation. Imagine you're a detective put in charge of figuring out relationships between various factors in your school, like the relationship between students' study habits and their grades. However, instead of traditional measurements, all you have are the rankings of these factors. This is where Spearman comes into play. Developed by the British psychologist C. Spearman, this method allows us to explore correlations between rankings when precise measurements are either challenging to obtain or simply impossible. For instance, think about how we assign value to things like beauty or honesty. These aren't easily measurable in numbers, right? But we can rank them subjectively. Spearman's method is particularly useful for assessing nonlinear relationships, which means it can uncover connections that aren't simply going up or down in a straight line. It allows us to evaluate variables that are tricky to quantify. By the end of this presentation, not only will you understand how to apply this fascinating statistical tool, but you'll also be keen to think critically about the world around us, assessing relationships you once took for granted. Now, let's break down what Spearman's rank correlation actually is. At its core, it measures how closely the rankings of two different variables are related. Imagine you're ranking your friends based on how well they play basketball versus how well they play soccer. Spearman helps you see if there's a correlation between these rankings. What makes this method unique is that it deals specifically with ordinal data, which means we can rank things but can't measure them directly like we can with height or weight. This is essential because it gives us insight into not just whether the rankings move together but also to what extent, hence the correlation coefficient, which ranges from 1 to +1. A perfect positive correlation, 1, means if one ranking goes up, the other does too. A perfect negative correlation, 1, means that if one ranking goes up, the other goes down. Understanding this coefficient can help you see the big picture in various fields, from social sciences to market research. By using ranks instead of raw data, we focus more on the relationships rather than on precise measurements. Think of it as looking at the forest instead of just the trees. Let's talk about how we can apply Spearman's rank correlation in our everyday lives. Have you ever tried to understand the correlation between students' heights and their ages? In a remote village where there aren't any measuring tapes or weighing scales, you can still rank students based on their heights. This method would allow us to analyze those rankings and determine if taller students tend to be older or not, without needing the exact figures. Moreover, let's consider more subjective attributes like beauty or fairness. You might ask a group of friends to rank each other based on these traits. Although it might spark a bit of debate, such rankings can help to establish correlations that might otherwise be overlooked. Spearman's correlation shines in these contexts, as it accommodates qualitative data that cannot easily be quantified. This statistical method is widely used in sociology and psychology, where researchers often deal with data that can't be measured neatly. For instance, you might see it in studies assessing kids' preferences for different toys based on their social skills, much easier to rank than to assign a number to. Now, let's compare Spearman's rank correlation with Pearson's correlation coefficient, another method you might have heard about. While Pearson measures linear relationships based on raw data, Spearman provides an alternative that has its own advantages, especially when it comes to dealing with challenging datasets. One significant advantage is that Spearman's method is not influenced by extreme values or outliers. Think about a scenario where one student scores exceptionally low in a set of grades. This outlier might skew the results if you were using Pearson's correlation. In contrast, Spearman remains unaffected because it focuses on rankings, allowing you to see the true pattern of relationships without the noise that outliers can create. Additionally, Spearman is beneficial in situations where the data is skewed, in other words, where the distribution is not symmetrical. It works brilliantly even with small sample sizes or when data doesn't meet the normal distribution assumptions. This makes it a versatile tool for researchers and analysts across different fields. So remember, while Pearson and Spearman have their place, knowing when to use each method enhances your analytical toolbox. As promising as Spearman's rank correlation may sound, it's essential to understand its limitations. One limitation is that because the method relies on ranks, it might miss out on nuances present in the data. By replacing actual values with ranks, you lose some information that can be crucial for a deeper analysis. For instance, if an area in your data is densely clustered, Spearman's approach might underestimate the strength of the correlation. This is especially true when data doesn't have a clear ranking structure. If the data points are so varied that ranking feels arbitrary, Spearman might not give you the best picture of the relationship at hand. Moreover, if the variables reveal a linear trend, meaning they correlate nicely in a straight line, Spearman can be less accurate compared to Pearson's method. This places limitations on its use cases. It's important to know that while Spearman effectively captures order and ranking, it might not always provide the complete data context needed to draw conclusive insights. So, while Spearman has many strengths, it's always crucial to weigh its limitations against the specific needs of your analysis. Let's look at a critical component of Spearman's rank correlation, the formula itself. The Spearman correlation coefficient is calculated using the formula backslash ra is equal to 1 backslash frac 6 backslash sigma d2 n3 n backslash. This might look a bit intimidating at first, but let's break it down piece by piece. First off, backslash ra backslash stands for Spearman's correlation coefficient. The backslash n backslash represents the number of observations or pairs you're examining. Now, what does backslash d backslash represent? Good question. Backslash d backslash is the deviation of ranks, which means you're looking at how far apart the ranks of two variables are. By squaring these deviations and summing them up, backslash sigma d2 backslash, the formula emphasizes larger discrepancies between ranks, making those variations more impactful in your results. Thus, this formula is not just a series of numbers, it is a structured way to understand how rankings relate, emphasizing the significance of deviations. Grasping the mathematical representation of Spearman's rank correlation helps pave the way for deeper analysis of both your data and the relationships at play. Spearman's rank correlation possesses several properties similar to Pearson's correlation coefficient, which is reassuring for one. Both coefficients range from 1 to plus 1. This means that interpretations of their values align. A perfect positive correlation, plus 1, means ranks move together in unison, while a perfect negative correlation, 1, signifies they move in opposite directions. Another fascinating aspect is that Spearman's correlation can help assess nonlinear relationships. Imagine a situation where two variables don't just map cleanly onto a straight line but might curve or twist instead. Spearman can still help us uncover and present those correlations. However, we must remember that while these properties provide useful insights, Spearman's correlation still has significant limitations. It doesn't capture all the information that raw data would provide, leading to potential inaccuracies. Therefore, it's crucial to consider what type of data you're dealing with when employing Spearman's method. Being aware of these properties will help you make informed decisions in your analysis. Focusing on rank and deviation is crucial for grasping Spearman's rank correlation. When we talk about ranks, we are essentially organizing data into an order based on specific values. Imagine if we rank students based on their heights, the tallest student gets rank 1, the next tallest rank 2, and so on. The deviation, represented by backslash, the backslash, tells us about the differences between two ranks. The deviations help reveal how closely related these ranks are. Smaller deviations generally indicate a stronger correlation. This is because when one student's height and weight rank closely, you can infer there is some underlying relationship. To put this into perspective, think of a class where students are ranked both by their height and weight. By examining the ranks, we can recognize patterns. When we see systematic deviations, we can decisively assess how closely these rankings align, a crucial step in determining correlation. So, reliably assigning ranks and understanding deviations is foundational in applying Spearman's rank correlation effectively in any analysis. One of the intriguing aspects of Spearman's rank correlation is how it embraces nonlinear relationships. Unlike Pearson's correlation, which fits a straight line between data points, Spearman can appreciate a variety of instance behaviors so long as we are considering ranks. The direction of the relationship is also key. A positive direction indicates that as one variable increases, the other does as well. A negative direction, however, shows that as one variable increases, the other declines. Visual representations, such as scatter diagrams, help illustrate these relationships and make complex interactions much clearer. To further visualize this, imagine plotting data around students' height versus weight. A straightforward linear relationship would show how weight typically increases with height. However, if we encounter a curve in our scatter plot, Spearman's takes note. It helps us see correlations that exist beyond mere upward or downward trends. Use these tools to represent complex data relationships creatively, enhancing our interpretations of the world around us. Let's walk through a practical example to solidify our understanding of Spearman's rank correlation. Suppose we want to determine the correlation between students' ranks in height and weight. First, we would rank each student based on their height, giving each a unique rank. Next, we would do the same for their weights. Following this, we can apply the Spearman formula we reviewed earlier to compute the correlation coefficient. Now, what answers do we hope to uncover? Would we find a strong positive correlation, meaning taller students are generally heavier? Or perhaps a weak or negative correlation, suggesting no clear relationship? By analyzing the results, We can engage in meaningful discussions about the nature of these variables. This exercise not only reinforces the formula but also empowers you to apply statistical concepts to real world data, enhancing your analytical skills in everyday scenarios. As we discuss the differences between Spearman and Pearson's correlation coefficients, it's crucial to understand their unique strengths. Pearson, which measures linear relationships, analyzes data based on actual values, like raw test scores. It works well when data follows a normal distribution and is linear. In contrast, Spearman takes a different approach by focusing on rankings rather than raw data, functioning effectively with nonlinear relationships. Essentially, when reporting correlation, the method you choose should align with the type of data you're analyzing. Consider how the two methods fare in different scenarios. For instance, if you're comparing students' scores across various subjects in a standard exam, Pearson may suffice. But if you're exploring rankings based on subjective traits, such as creativity in art projects, Spearman would be your go-to method. Ultimately, knowing when to apply each method can significantly enhance the depth of your analysis and lead to better, more informed decisions. To truly understand Spearman's rank correlation, let's engage in some hands-on activities first. Gather a set of data. Consider something relatable like students' exam scores. After ranking the scores, you can apply the previously discussed Spearman formula to calculate the coefficient. We could also take a moment to discuss the subjective factors that may affect our rankings. For example, in the beauty rankings, how might different cultures influence our perspectives? Alternatively, let's analyze scatter plots to identify directions of correlation based on our data samples. As a group, let's brainstorm some rank-based research questions tailored to our interests. Perhaps we'll explore friendships based on the number of similar interests, using rankings as our analysis method. By integrating real data, we can not only deepen our understanding but also foster an interactive and collaborative learning environment. Let's recap what we learned. 1. What is Spearman's rank correlation? Spearman's rank correlation is a statistical tool developed by C. Spearman. It helps us understand how two things are related when we can only rank them, not measure them directly, like in the case of students' heights and weights when measuring tools are unavailable. 2. Understanding nonlinear relationships. We can use Spearman's rank correlation when we want to see relationships between things that don't change in a straight line. For example, when looking at qualities like honesty or beauty, which can only be ranked and not precisely measured. 3. Handling extreme values. One of the great advantages of Spearman's correlation is that it isn't affected by extreme values or outliers. This makes it more reliable than other correlation methods, especially when some data points are far off from the norm. 4. Formula and interpretation. The Spearman's rank correlation coefficient helps measure how strongly two ranked lists are related. The formula is backslash r underscore s is equal to 1 backslash frac 6 backslash sigma d2 n3n backslash, where backslash d backslash represents the differences between the ranks of each item. Just like with simple correlation, this coefficient ranges from 1 to +1, indicating the strength and direction of the relationship. Real-world connection. For example, when ranking students' performances based on their scores without exact numbers, this principle helps us understand how rankings correlate with their study habits. Encouragement to engage. You've now unlocked the basics of how relationships between different qualities can be understood using ranks. This knowledge will not only boost your statistical skills but also help you make informed decisions based on data in your future careers, like in marketing or research. We've covered a lot today about Spearman's rank correlation, and as we conclude our lecture, I encourage you to reflect on its real-world applications. Correlation analysis is vital in statistics, and Spearman provides a unique lens through which we can understand relationships that are often overlooked. Now, I'd like to open the floor for any questions or clarifications regarding today's content. Don't hesitate to ask furthermore. Explore additional resources for further reading and understanding of correlation analysis. Before we end, I hope you are inspired to apply your newfound knowledge in your own research projects. Remember, whether it's exploring relationships in school or measuring trends in your life, understanding correlation will elevate your analytical skills. Thank you for your attention today.